talk's really for back-end developers of server apps, P2 plugins. So who here would describe themselves as a back-end developer of P2 plugins? Awesome, we're all in the right room. That's good. OK, so a little bit about me. Thanks for the sound. Like Mel said, I've been at Atlassian about 6 or so years. But it's my first Atlas camp, so I'm really excited to be here. Anyone else here for the first time? Oh, OK, quite a few. Cool. I'm from sunny Sydney. And probably the most important biographical thing about me is that I'm on the Java platform team for the server org. So like Mel said, we look after active objects, app links, streams, gadgets, a whole raft of common modules that underpin all of the 6 server products, including the P2 plugin system. And we're also getting AMPs and UPM and the SDK. So we are busy. So when I say components in the title of my talk, what am I actually talking about? Well, this is probably news to none of you, but all server products support apps, or plugins, as we would call them in the old days. Apps are made up of components, which really under the covers are Spring Beans. Some of those components are internal to your app, and you can export them to OSGi if you choose to. Whereas others belong to other plugins, and you import them from OSGi because you want to invoke some method on them. That's all great words, but most people prefer pictures, so let's have a look at that in a diagram form. So here we have our product. That could be Ficru, Bamboo, Jira, Crowd, Confluence, Jira. It really doesn't matter. They all work the same way. The product, during its startup cycle, starts the OSGi container, which is Felix. And that, in turn, creates what's called the service registry. Does anyone know about the service registry? You probably all do. OK, so the service registry is just like a huge multi-valued map where the keys are Java interfaces and the values are all the object references that implement that interface. So any P2 app can register a service into the service registry or look up a service from the service registry. So the product itself deploys itself to the OSGi container as what's called the system bundle, or bundle 0. Whereas apps are also deployed as each as their own separate OSGi bundle. I'm sure this is all revision for most of you, so be patient. There's good stuff coming. The plugin system gives each app its own Spring application context. So in app 1, for example, there might be a bean A. And in app 2, there might be a bean B, and the developer of app 2 has decided to export that bean to OSGi as a service. Now, app 1 might import that as a service from OSGi, and that would create a bean called, let's call it B prime. It's the same Java type as bean B, but it's really just a proxy to the service, to the component that lives within app 2. And app 1 might have another bean, another component C, that depends on type A and type B. And this all works fine at runtime because C needs an A and a B, and there is an A and a B in the same application context, so that the auto-wiring is successful. C has no idea that B prime is actually a proxy to a service that's coming from another app. It just, as far as it knows, it wants a B and it gets a B. OK, so that's sort of a good recap to bring everyone to the same level. Let's talk about what the developer's options are at the moment for defining all of those components. What are the current technologies? The first one is to define them within your plugin.xml or your plugin descriptor. That's how the plugin system originally worked. We're talking about P2 plugins here. And what it involves is, for your internal components, you would just add a component tag to your XML. You'd give it some key, and you'd say what class you wanted the plugin system to instantiate for you. To export a component, it's much the same thing. You just have a component tag, but you add the public equals true attribute. I think I've got a pointer thing here. You add the public equals true attribute, and that will cause your component to be exported to OSGi. To import a component, it's not too different. You just say component import, you give it some key, and you say what interface you're looking for in the service registry. And that would create the proxy bean that we saw before, the B prime bean. To create a module type or a custom plugin point, you would do much the same thing. You'd say module type, you give it some key, and you'd provide the class that's your module descriptor factory. Who is a developer of an app that provides a plugin point? OK, so it's kind of an edge case, but it's really part of the power of the plugin system that plugins can define plugin points to be used by yet more plugins. So it goes, I won't go on about that. So some of the downsides of plugin XML, there's a runtime cost. So this is how P2 originally worked. A developer would simply create a plain old jar file and ask the product to deploy it as a plugin. The product would inspect it and look at the manifest and say, hey, this is not an OSGi bundle. I'm going to unzip this jar file, and I'm going to generate the OSGi headers in the manifest file, and I'm going to zip it all back up, and then that's what I'm going to deploy. So that obviously comes with a fair cost at runtime. Plugin XML is not super flexible. You're allowed certain elements and certain attributes, and that's it. For example, you can't say which constructor you would like to be invoked. You just hope that the auto wiring works. It's become a little bit unreliable in recent times. If you are bundling a dependency that was built with Java 9, then you may well have module info classes contained inside your plugin jar. And what's interesting about those classes is they have no superclass. So that's really unusual for Java developers for there not to be, everything has a superclass, right? But some of our code expects a superclass, so you can get things like null pointer exceptions. So we're starting to see sort of some cracks in the old system. Also, the tooling is not a great developer experience. By its nature, the plugin XML is highly extensible. As I said before, new plugin points can define new element types. So it's impossible for Atlassian to provide a schema for these XML files. So your tooling can't do things like code completion. You don't really get any help with it. You're on your own. You've got to make sure you get it right. Okay, so just a quick recap. Who is using plugin XML to define their components? Still some people? Okay. Okay, the second technology that's available to you at the moment, it came in about 2013, is Spring Scanner. Who's using Spring Scanner? All right, so most of you. I won't spend too long explaining how it works then. So obviously your internal components, you annotate them with the dependency injection annotation of your choice. You can export things using @exportAsService. You can import things using @componentImport. And you can declare module types with @moduleType. So hopefully that should be intimately familiar to people that use Spring Scanner. Having done all those annotations, then you're relying on this build chain. So the first step in the chain is the scanning for annotations. So at build time, when you run Maven package, the Spring Scanner Maven plugin will scan the code within your plugin jar and optionally some of your dependencies. It'll scan it for the common dependency injection annotations, like its own ones, for example, component import, but also third-party ones like Spring's @component or @named, and so on. So that scanning happens first, and then Spring Scanner writes those, what it finds, into what are called index files. So they are just plain text files, and they're just like a laundry list of class names, and sometimes there's a bean name appended to it or whatever. So that's a proprietary format that we generate into those files. Then during the packaging step, those files get bundled up into your jar file, and at runtime they'll be available in the plugin components folder. So all the products at the moment contain the Spring Scanner runtime, which then looks for those index files and uses them to generate the bean definitions that will define your components of your plugin. So that's how Spring Scanner works under the hood. Did anyone learn something from that, or that's all old news? A couple of people learned something? Cool. So what are the good parts about that? Well, firstly, there's no longer any transformation. This is why most people migrate to Spring Scanner, is to remove that time-consuming transformation step that used to happen at runtime. So the nice thing about that is you can look at your jar file after you've run Maven package, and you can see exactly what's going to be deployed to the product. You're not sort of guessing about what the product is going to do with your jar file. There's less XML. So in your plugin XML, you no longer have a huge list of components. That's all gone. So your XML is now boiled down to the real parts of your plugin, so your web items or your REST endpoints and so forth. Some of the downsides, though, that long tool chain. I mean, there's a lot of places where that can go wrong. And in my team, we're kind of the place of last resort for developers who've come unstuck and are having problems working out why the hell their plugin doesn't wire up. And we've seen all kinds of problems. For example, they might not be scanning the right dependencies, or they might be generating the index files correctly, but because of how they've misconfigured the build section of their POM, those files don't ever get copied into the jar file. So at runtime, there's no files for Spring Scanner to look at. So another downside is the @component import annotation, and people who use Spring Scanner probably know what I'm talking about here. There's no really good place for it. I mean, let's say you're writing a Jira plugin and you want to use Issue Manager. You probably annotate Issue Manager in your constructor parameters. You annotate it with @component import, right? Well, what if 10 of your components need Issue Manager? You have to put this annotation in 10 different places? You only actually need it in one place. But let's say you only have it in that one place and then you delete that class, suddenly all the other places break. So you've really got to put it everywhere just to be on the safe side. Some people take the approach of having one separate file that has all their @component imports and keeping that out of all their production code. But then that file's isolated from all the other code, and you've really just got to hope that that list of types matches up with what you actually need in all your constructors. So we've found that there's really no good place for those annotations. Spring Scanner also has a limitation, I guess you could call it, of how it names things by default. So Jira developers, or Jira app developers may have run into this. The classic case is application properties from Sal and Jira. They both have the same simple name, and by default, Spring Scanner will use the simple name with the lowercase initial letter as the bean name. So what will happen at runtime is you'll have your two @components, you'll have your two entries in your index file. At runtime, Spring Scanner runtime will see the first one and say, oh, you want Jira's application properties? I'll make a bean called application properties, and that'll be your Jira application properties. And then it gets to the next line, it says, oh, you want Sal's application properties? I'll make you a bean called application properties, and that'll go into your bean definition map. And that will overwrite the bean that was representing the Jira application properties, and now you've got one bean where you expected two, and your auto wiring is going to fail. So there are workarounds, but it's a really tough situation to diagnose. When you see it happen, you go, why is that? I'm sure I imported that. Why is there no Jira application properties? So that's a bit of a gotcha. Another downside is that your dependency injection concerns leak into your production code everywhere. So all over the place, you've got these little component imports all over your production code saying that you need a particular service from OSGi. And finally, it's an Atlassian-specific thing. You could hire someone that knows Spring inside out and knows OSGi inside out, but you're still going to have to train them up in how Atlassian's Spring Scanner works and how to debug it when it doesn't work the way you expect it to work. So the third technology that you have available today is Spring XML. That's been something that's there since the Spring framework was invented. The way it works in the plugin system is any XML file that you put into meta-inf Spring will be picked up and processed by the plugin system as a source of bean definitions. So you add bean elements to that. You can use the OSGi namespace to import and export services. The upsides of that are that all your dependency injection concerns are back in one spot again. That's pretty cool. Tool support isn't too bad because there is a schema for the Spring XML files, and modern IDEs will quite happily tell you if you've made mistakes or if everything looks good in your Spring XML files. The downsides, though, are, again, because it's XML, it's a little bit inflexible. So you can only do what the schema lets you do. And to be fair to Spring, there are a lot of things you can do, like you can call a static factory method, or you can pass constructor parameters, or you can call setters. You can do those kinds of things, but you're still limited to what's in XML. It's very hard to reuse XML files, though. You can import one into another, but that's about the extent of how you can compose them. The dev loop is relatively slow, so you can put in the XML that you think will work, but it's really only a deploy time that you find out whether it will work. So I'm going to talk about another option now, which is using Spring Java configuration. So who's aware of using Java configuration in Spring in general? A few people, OK. So most people, when they started using Spring, they wrote XML, and that's how they define their beans. But for a long time now, Spring has supported the idea of defining your beans in Java code. So that's what I'm going to talk about now. That's been a thing in Spring since 2009. And the way it works is you put classes in somewhere in your project, and you annotate the class with that configuration. That tells Spring that this is going to be a source of bean definitions. And within that class, you write a number of methods, and each one you annotate with that bean. And then you can compose those classes in the way that you can compose any other classes. So you can use inheritance or composition, or you can also use an import annotation, which is another Spring annotation to import one class into another. So you could have a master class that imports classes from or other configuration classes that you've written. But the really cool bit is that it supports this other annotation called @conditional. So that allows you to conditionally add beans to your application context, which is not something you could do with the other approaches I've talked about before. Maybe Spring Scan to a certain extent. Has anyone used Spring Boot? Yeah. The way, it's pretty magical, right? You might have the servlet API in your class path, or you might have a JDBC driver in your class path, and Spring Boot will automatically create bean definitions for all the things that go along with that. It might create a data source bean, or it might create a dispatcher servlet. It might do all these things seemingly by magic, but under the hood, it all uses conditions. So that's what I'm going to talk about here. It's the same conditional annotation that Spring Boot uses under the hood to do all those things. So everyone loves code, so here's some examples of what configuration actually looks like in Java code. So you might write a class called mySpringBeans, and you might create a method called fooService, and in that you simply return the instantiation of the concrete type. So you're literally invoking the constructor programmatically, which is a big difference to putting a class name in an XML file and hoping for the best. Okay, so the compiler is going to tell you what you've missed out. The return type is the interface that's being implemented. So that's the simplest possible example. Here we're applying a condition. So we just put @conditional in addition to the @bean, and we nominate what condition we want to determine whether this bean ever gets created or not. And just to show you what a condition might look like, here's the most trivial one. Here we've got, we just implement the condition interface, which has one method. There's some context you get about the annotation and about the application context itself. And then it's just up to you to decide what the implementation is going to be. In this case, it's hard-coded to true, so it's pretty meaningless. But you can imagine your own logic would go there about whether you want this bean to be created or not. So here's some more examples. Here, the fooService impl has gained a dependency via its constructor. It needs a BAS service in order to be constructed. So in this case, we're just calling another bean method. So BAS service, let's imagine BAS service is another @bean method. We can just invoke that method to provide the dependency that the fooService implementation actually needs. Another way to do the same thing is to have the BAS service be an argument to the fooService2 method. So in that case, you would just pass it straight through to the constructor as is. And those two methods are really equivalent. So the first one I call the method call style, and the second one is the parameter style. Okay, so what are some of the upsides of this approach? Well, firstly, it's Java code, right? So it's super powerful. It's a 4th generation language. You can do whatever you like. It's instantly familiar because we all know Java. That's why we're here. And the tooling is obviously superb around Java, whatever IDE or editor you're using. Conditions, how powerful are they? So especially if you're writing a cross-product app or a cross-version app that has to work between Jira 7.4 and Jira 8.3 or something, conditions are really going to help you out with creating beans in some situations, but not others. It's nice and simple. The tool chain is super short. You write some code, the compiler compiles it, and at runtime, Spring will execute it. So you can't get shorter than that. And it's super clean, because now there's no dependency injection concerns anywhere in your production code. They become almost POJOs. They express their dependencies in their constructor, and they don't care or have any opinion about where those dependencies come from. That's the way it was really meant to be. Okay, everything has its downsides, I guess. One downside, and it's not really a downside, but you have more dependencies to manage. If you're going to write more code, you're going to have more dependencies. There's no getting around that. It's still code, so you've got to keep it under control. Don't go nuts, and don't make your classes super long, or don't put too many methods in one class, or don't put too much logic within a bean method. I mean, that's just basic software engineering. And if you want to use OSGi services, there's a bunch of boilerplate code that you're going to have to write. But if you stay in your seats, you'll hear an Atlas Camp exclusive. Okay, so now I'm going to talk a bit about how you would actually use that as a server app developer. In terms of product support, to use Spring Java config, you need Spring 3.x. And that means you need plugins 4.x, which is built into platform 3.x or later. These are all or later. The good news is that every currently supported version of every server product already includes support for all of those versions. So you can use Spring Java config today in your server app, no matter what product it's for or what version it's for. So here's how you would actually register one of those config classes if you're writing a P2 app. There's two ways. The first one is to provide this pair of elements. So context annotation config turns on the bean post processes that are necessary for Java config to actually work. And then you just define your config classes as anonymous beans. So there's no bean ID here. You just say to Spring, I want that to be a bean. And it'll look at it and go, oh, that's annotated with that configuration. I'm going to use that to get more bean definitions. You can list as many of these bean tags as you like, or you can just list one master one and have it import all the other ones. It's really your choice. The other way to do it is to use the component scan tag that some of you may already know just for finding regular components in Spring, and you give it a base package. Ideally, you would put your config classes in one super specific directory or in one super specific package and just scan that one package, because that'll be a lot quicker than scanning your entire code base, for example. So those two approaches are equivalent. So how would you actually import an OSGi service? Well, you would write a method like this. Let's say you wanted application properties. It doesn't matter if it's the Sal one or the Jira one, because this is code, right? The compiler knows. So you call a method import OSGi service. You pass it application properties as an interface, and you get a reference to the service. How good is that? To export a service to OSGi is pretty similar. You, first of all, need a bean method that creates the thing you want to export. I mean, no one's going to do that for you. And then you create a second method called export, well, call it whatever you like, and you call export OSGi service. You pass the instance that you're exporting. You pass the interface, or can be multiple interfaces. This is a vararg argument here. You pass the interfaces that your instance actually implements, same as you would in Spring Scanner. And you can pass a map of service properties as well. That's a native OSGi concept. Every service in the service registry has a map of string to object that has whatever metadata you like. So there's support for that as well. So you can put whatever you like in here. You can even make it null if you don't have any special properties to add. So defining a module type, for the few of you that are doing that at the moment, that's not too different. First of all, you have to instantiate your module descriptor factory. You do that programmatically like everything else. And then you need a second method that exports that module type to the OSGi service registry. So this is using the method call style that I was talking about before. I'm really just invoking the method that I've already defined up here. I'm invoking it down here to get the instance, and I'm saying push that out to OSGi as a module type. Okay, some of you are probably scratching your heads and going, well, this is fine, Andrew, but where are all these helper methods coming from? Well, Atlas Camp exclusive, my team has written a small helper library to provide those methods and a few other handy things to help you get started with Spring Java config. So here it is. It's hosted in the Atlassian public Maven repository, and that's the current version number. But obviously, you can go to packages.atlassian.com and find out the latest version number at any time. So what do you get inside that library? You don't get any steak knives, but what you do get is helper methods. So there's that helper method to import an OSGi service that we saw, import OSGi service. You get a method to export an OSGi service. You get a method to define a module type. You get some conditions out of the box. For example, if you only want your bean in a certain product, then there's a condition for each of the 6 products, or 7, including refapp, if you care about refapp. So that's analogous to Spring Scanner's at Jira component or at Confluence component annotation. So we're not taking anything away from you there. There's a generic system property condition where you name a system property and what value it needs to have in order to be true. And then you just nominate that as the condition on your bean. We've written a special case of that, which just checks whether you're in dev mode or not, just in case you find that useful. We provide some pre-built configuration classes that bring in the module factory from the product and also the plugin accessor. We really chose these two because they're the things you're going to need if you're defining a module descriptor factory. So if you're defining a new plugin point, you might find it handy to import these configuration classes just to get the module factory. Or you could just write your own import OSGi method for that. It's just the same as the other ones. There's a few other little odds and sods. It's easier to write a module descriptor factory because we provide a convenient superclass that does that for you. The library will automatically generate some package import statements that you need in order for all of the Spring Java config to work, and I'll explain what they are in a later slide. But if you use our library, you get they get those imports for free. In terms of Maven dependencies, you'll need to add these dependencies to your app. The first one is Spring Beans, and then we've got Spring Context. You probably already have a dependency on those anyway. You just may not have it explicitly expressed in your POM. So for example, if you're using @component on any of your components, then you're already using these dependencies. You'll need a dependency on Felix or the OSGi framework. You could use the official OSGi library, but I find it's more convenient just to use the Felix dependency because it provides all the same types, and it's much easier to align the versions of Felix with the version of Felix that the product actually uses. And then there's our new helper library, the OSGi Java config library. That's completely optional. You can write the boilerplate yourself if you prefer to do it that way, if you don't want to rely on our library, but it's super small and it won't cost you much to bundle it into your app. Okay, so those packages I talked about. So when you're writing your OSGi instructions in your POM, in the import package section, you'll need to add these 3 packages. They're all Spring packages that are used by the Spring Java config mechanism, and the bind tool will not detect these for you. Unless you use our library, in which case we've deliberately put in references to types that are in those packages inside our library, so bind will detect references and will automatically generate the right package imports. If you do decide to go this way, here's a few tips that I'd give you. First thing is keep it simple. Don't go nuts creating huge long classes or complicated methods or too many methods. Try and break it down into some coherent structure. Be consistent with your style, so either use that method call style or the parameter style for getting the dependencies of each bean. Try and stick to one way or the other, don't mix them willy-nilly. Be aware that Spring will actually turn your bean methods into bean definitions, so it might not execute them when you think it's going to execute them. What actually happens at runtime is that Spring will create a cglib subclass of your configuration files, and that will perform certain things like caching and so forth. So if you call a bean method programmatically over and over, if that's a singleton bean, you'll still only ever get one instance. So you don't have to worry about that kind of thing going off the rails. This is not really advice, it's more of an option you have. When you're writing your configuration classes, if you're cunning about it, you can split them up in such a way that all the OSGi stuff is in one @configuration class, and all the non-OSGi stuff is in other @configuration classes. And then at test time, you could leave out the OSGi class and substitute it with a class that provides mock beans, for example. Then you can imagine doing integration testing of your app without a product even running. So just to summarize the benefits of the Java config approach, it's super powerful. You've got all the power of Java at your disposal for doing whatever you want. You can call constructors, you can call static methods, you can call setters, you can do all 3, you can do if, then, if, else, switch, this, that. You can go nuts, and you can apply conditions as well to make sure that beans either appear or don't. It's very reliable. It's a really short tool chain. You write code, the compiler compiles it, it gets executed at runtime. There's no index files or packaging or bundling or unzipping or rezipping or anything going on. It's very familiar, not just to you, but also to anybody you might hire off the street. If they know Spring and they know OSGi, then they're immediately going to be productive. They don't have to be inducted into the ways of Spring's gonna. It's very clean. So all your dependency injection concerns are now back in one place again. They're in your @configuration classes. They're not spread throughout your production code, which that's a really attractive benefit. So here's, I'm going to put up a slide showing you where you can go to find out more about this approach. But just a quick poll first. Having heard all of this, who thinks they might give it a go in one of their apps? Awesome. Wow, I couldn't have hoped for better than that. Okay, so here's some links. We've got a sample project up on Bitbucket that shows you this in action. So it's a sample app. We've got some public documentation up on developer.atlassian.com explaining everything I've talked about in my slides. So if you just get one link, get that one there, and that will give you everything that I've explained today. If you want the official Spring documentation, there's no better source for the truth than that. So obviously it won't tell you anything about OSGi, but it'll tell you all about using Java configuration in Spring. And this is a YouTube tutorial that some random guy just made, but I found it particularly useful. So if you're new to Java configuration and you want to go into a bit more depth about how it works and what the possibilities are, then I recommend that tutorial as well. It's about 40 minutes long or something, so it's pretty detailed. That's all I had, so I'll throw it open to questions.